Hello everyone, welcome back to the channel. This is episode 12 of series where we are building clone of PDF.AI app. Today we are going to build a simple PDF question answering pipeline using LangChain. But there is a twist. We are not going to use embeddings of vector databases. We'll understand what is embedding and vector database in the next video and we'll utilize that in our pipeline. But instead today we'll directly stuff the entire PDF content into a single prompt and ask questions on top of that. So this is the fastest way to get started, but it's not always the best. So please stick around in this video. I'll just show you how to use this approach and what are the limitations and why this might not be used for scaling. So let's begin our project. We'll start with creating a basic pipeline where we'll be using PyPDFLoader to load the document and then use QA chain to ask queries on top of it. So with that, let's get started. All right. So first thing we need to do is import few basic modules. So we'll use LangChain community.document loaders to import PyPDF loader. It's one of the best which LangChain provides in terms of loading PDF content. You can use any other loader as well. It won't matter much. And then we'll need to load OpenAI. All right. And the third and last thing we need to do is import load QA chain.change.question answering import load QA chain. Okay, and now what is load QA chain and why are we importing that? We'll understand in brief about this once we use this module, but I think that it deserves a separate video altogether because it has multiple features which it can provide you. So maybe we'll think about this in some other video, yeah. But for this course, we'll keep it a little crisp. We won't try to get deep dive into what load QA chain is. Yeah, all right. So first step which you need to do is load the PDF. So we'll do using PyPDFLoader. I'll create a loader instance, PyPDFLoader, and I've already downloaded a sample PDF. Now what this PDF is, I've just used Morgan Stanley's earning release. So I'll just show you the PDF. One second. Yeah. So this is the document which I downloaded. You can download it just by searching Morgan Stanley earning release. I downloaded the quarter earning press release, and I've just stripped out all the pages. I've just kept the first pages so that it's easy for me to demo it on. All right. Let's go back to our code. Now I'll do pages equal to loader dot load just to load the entire content. Now second step we need to do is create an LLM object. In order to do so, we need to define our API key and then create a chat open API object. So let me just get my API key real quick. All right, we have our API key. Now I'll just define OpenAI. Okay, so my chat OpenAI. Okay, I think we did import a wrong chat OpenAI. We need to import. Okay, sorry, my bad. All right. Now this takes multiple arguments like model, temperature, and the API key. Just to give you a context, temperature means the quality of response. So with lower temperature, it would be more crisp. With higher temperature, it would start to be more creative in a sense. So since we are talking about financial document, we want it to be very concise and clear. So we'll just give temperature as 0 and I think I'll define a model this time. Until now, we have never defined any model, but this time let's go with 3.5 turbo. All right, and the last thing we need to give is the open API key. Open API, sorry, open AI API key. I think yeah, equal to API key. All right. Now, once this is done, we need to run our query on a QA chain. So for that, let's define a query. Let's say what is this document about? Very simple question. And then let's load up the chain type equal stuff. Now, if you see, I've used load QA chain and I've specified LM object and chain type as stuff. Now, Just I'll be very brief here. So what load QA chain does is it helps us, start a question and answering pipeline with the LM object. And what chain type stuff means is it will take the entire document object which you have given. It will load the loaded pages and it will create a single prompt out of it. So let's say we have a task called what is this document about? Then the prompt will be created something like she and this prompt will be created internally by the chain type stuff, and it will look like something. Here is some context, and it will say page one and some content of page one. Then it will say page two, some text from page two, and then finally, what is this document about? So this is how the prompt will be created and given to the LLM. So instead of us passing the entire page content, we are going to use load QA chain to help us do that. And there are multiple other chain type like retrieval. I think let me just check it real quick. I have this open in my other tab just so you know. I'm just going through my notes. So yeah, so we have chain type, which is refine, map reduce, map re-rank, and many more. So what map reduce means is summarize each of the chunk which is present in the PDF and then combine it. So it's useful for long documents where, token size would reach the limit of the particular model. So there using map reduce is a bit beneficial. But yeah, for now we are just interested in stuff, so we'll go with that. Now, as I said, there are a few limitations to the approach which we are taking. So one of them being token limitations. For example, LLMs like GPT 3.5 or GPT 4 has a max token limit. So if your PDF is too long, the model will just ignore the overflow, and or it might fail with some error. So so if you have limited, I mean, there's only a limited amount this stuff uh, agent type can do. So we can't pass huge documents and expect it to work perfectly. And also there are a few other limitations like there won't be any semantic understanding. So there's no concept of semantic similarity search here. So if you ask a question and doesn't match the exact wording in the PDF, the model might not be able to answer it at all. Now this problem will be solved when we use the embedding approach. Also, it's quite inefficient for larger documents in the sense that the cost would reach much beyond what we expect for a simple question and answer uh, platform to do for a PDF, and that's not what we want. So if I have something else open, one second. So this is my OpenAI dashboard. So if you see here, we have used 11,673 tokens until now. So in all the videos which I have built and all the exercise which I performed before building the video, the total token I used is 11,673. But what I'll do is I'll run this simple query which has just one page PDF and we'll see how many tokens increased. So let's go and run this code, right? All right, let's run this. I did get an answer here. Okay, yeah. Okay, what just happened? Oh, sorry, we didn't complete the code. My bad. We just loaded the QA chain and then left it as is. So let's put responses chain.run. Now input documents would be the pages which we passed, and the question would be the task which we have asked for. And then we'll just print out the response and see what's the response which we receive. All right. So if you see, it did give us a brief about the document that it's a press release for Morgan Stanley, which is reporting the first quarter earning of 2025. So yeah, it did do a good job, but let's go and see the amount of tokens which we exhausted. So last when we checked, it was 11,673. Let's refresh the dashboard, and it is 13,757. So around 2,000 tokens which were exhausted in a single call. And just think if the document is used, let's just say we would have used the entire PDF, which was 16 pages long. So we would have been exhausting 16,000 tokens every time a query is made and every time a follow-up query is made. So it would have been quite an expensive task for us, and that is why it's not a good way to build the app which we are trying to build, which is the clone of PDF.AI app. We want to eventually reduce the cost, reduce the token usage, and then ultimately reduce the cost which is incurred by our models. So for that, what there's another concept which is called the embeddings and the vector stores. So we'll be understanding about those concepts in the next video. We'll implement those concepts in the further videos, maybe around 2 videos. And I think we'll be able to implement it in enough for us to get a quick understanding of the concept. So with that, I think that's all for the video. I hope you liked it. I'm sorry for some mishaps which happened in the middle of the video. But yeah, please like and subscribe the channel if you like the video, and I hope I'll see you in the next video. Thank you.